the advent of more powerful processors in the early 2000s started the computing revolution that led to what we now call the cloud. With single hardware instances able to run dozens, if not hundreds of virtual machines concurrently, businesses could offer their users multiple services and applications that would otherwise have been financially impractical, if not impossible. But virtual machines, VMs, have several downsides. Often, an entire virtualized operating system is overkill for many applications, and although very much more malleable, scalable, and agile than a fleet of bare metal servers, VMs still require significantly more memory and processing power and are less agile than the next evolution of this type of technology. In addition to being more easily scaled, up or down according to demand, containerized applications consist of only the necessary parts of an application and its supporting dependencies. Therefore, apps based on microservices tend to be lighter and more easily configurable. Virtual machines exhibit the same security issues that affect their bare metal counterparts, and to some extent, container security issues reflect those of their component parts. A MySQL bug in a specific version of the upstream application will affect containerized versions too. With regards to VMs, bare metal installs, and containers, cybersecurity concerns and activities are very similar. But container deployments and their tooling bring specific security challenges to those charged with running apps and services, whether manually piecing together applications with choice containers or running in production with orchestration at scale container-specific security risk. Misconfiguration. Complex applications are made up of multiple containers, and misconfiguration, often only a single line in a .yaml file, can grant unnecessary privileges and increase the attack surface. For example, although it's not trivial for an attacker to gain root access to the host machine from a container, it's still a too common practice to run Docker as root, with no user namespace remapping, for example. Vulnerable container images. In 2022, Sysdig found over 1,600 images identified as malicious in Docker Hub, in addition to many containers stored in the repo with hard-coded cloud credentials, SSH keys, and NPM tokens. The process of pulling images from public registries is opaque, and the convenience of container deployment, plus pressure on developers to produce results fast, can mean that apps can easily be constructed with inherently insecure or even malicious components, orchestration layers. For larger projects, orchestration tools such as Kubernetes can increase the attack surface, usually due to misconfiguration and high levels of complexity. Final word: machine learning can reduce the risk of data breach in containerized environments by working on several levels. Anomaly detection, asset scanning, the transformative possibilities of container-based apps can be approached without the security issues that have stopped some from exploring, developing, and running microservice-based applications. The advantages of cloud-native technologies can be won without compromising existing security standards, even in high-risk sectors. Thanks for tuning in. If you enjoyed this, don't forget to like, comment, and share your thoughts below. Stay tuned, and we'll see you next time.